Review of probability. The addition rule of probability states that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. But if A and B are mutually exclusive, then the probability of A union B is simply the probability of A plus the probability of B. Tree diagrams. Tree diagrams can be used to illustrate multiple events, both for independent events, where the probabilities remain the same, and for dependent events or conditional probabilities, where the probabilities change. More information on tree diagrams can be found at this link. Now, a tree diagram with independent events. Here, the first toss of the coin is a probability of 0.5 for a head, 0.5 for a tail, and for the second toss of the coin, the probabilities remain the same because the events are independent. This is a tree diagram with dependent events. If we're doing a test and we know the answer 75% of the time, and we have to guess the answer 0.25 with a probability of 0.25. When we know the answer, the chances we'll get it correct, it's absolutely certain, a probability of 1. Chances we'll get it wrong are 0. But if we're guessing the answer, and for instance it might be 5 multiple choice alternatives, we have a chance of getting it correct of 0.2 and of wrong 0.8. In the Venn diagram here, the 4 regions are represented by the intersections shown. We can relate that to a probability table. So A intersection B, you can see where that is on the probability table, etc. The rows of the probability table add up to the probability of A and the probability of the complement of A. The columns add up to the probability of B and the probability of the complement of B. Conditional probability formula, probability of A intersection B is equal to the probability of A by the probability of B given that A has occurred, and if we rearrange this formula we get the probability of B given A is the probability of A intersection B over the probability of A. If A and B are independent, then the probability of B given A is simply the probability of B. And so our conditional probability formula of the probability of A intersection B equals probability of A by the probability of B given A becomes simply the probability of A and B is equal to the probability of A by the probability of B. But A and B must be independent for this formula. The law of total probability. Here we have in the first stage 3 possibilities, A, R or M, with the probabilities shown. And then in the second stage we can either get B or the complement of B. The probability of B occurring, there's 3 ways that B can occur. We can have A and B, R and B, or M and B. So the probability of A and B occurring is the probability of A by the probability of B given that A has occurred, and so on. And we can work this out. The total probability of B occurring is 0.019. If we look at this example, the same experiment, and we are concerned with finding the probability of M given that B has occurred, it will be the probability of M and B occurring over the probability of B. We've worked out the probability of B to be 0.019, and we can see the probability of M and B occurring is 0.009, which simplifies to 9 over 19. The end.